Hello. All right, pH. Might want to pause and write this down. All right, the pH scale goes from 0 to 14. Hi, need your attention? It's weird in that the weaker the acid or the base is, the closer it is to the middle. So it's stronger as it goes to the extremes. So I need to talk to you about that for a little bit. So I'm going to move to the board and make sure you understand this pH scale. Okay, if I have an acid, get off your phone and stay off, please. That's a pH of 1. Is it strong or weak? Very strong. All right, here's weak. If I have an acid with a pH of 6, is it stronger or weaker? Weaker. Good. So I'm going to put it in between. If I have an acid with a pH of 10,
Strong. Weaker.
very weaker. All right. So the acids get weaker as you go this way. Okay? The bases get weaker as you go that way. So let's do the same thing with bases. So, what's the strongest base? Good. What's the weakest base? 0. So give me a moderate base. Yeah, 8. Or 3 would be very, very weak. So let's do like 8 or 9 or 7 or 6. Somewhere in there. Yeah. So yeah, it'd be in there somewhere. So any number in between is going to be weaker than the strong one. Did that help?
Sort of.
I kind of felt like that helped until I just messed it up.
So is 7 the weakest?
7 is neutral. 7 is neither base nor acid.
If you're acid, 14 is still the base,
Yes.
acid's here is the strongest, if you're the base, 14 is the strongest.
Yes. All right, so you can think of the pH scale as acids, but then bases, it's exactly opposite. Okay? And the both pH of 7 is neutral and water is a 7. You need to know that. Water is a 7. Pure water is a 7. Yeah. Bases are opposite of acids. Yes. So if it's a strong acid, it's a weak base. If it's a strong base, it's a weak acid. Yes, it depends on which way they write the scale, but I've never seen it written backwards. So 0 to 14. Okay. Ready? Now, no, never mind. I'm not going to do that. Here are the 3 pH equations. You get these equations, and they look awful, but I promise you they're super simple. So let's jot them down, and then let's talk about them. Okay, are you good? So what's the pH of a solution with a hydrogen ion concentration of that? Okay. So all you do is you're going to use this equation here for pH. See where it says right here, hydrogen ion concentration? That's where I'm going to put this number. And then I'm just going to hit enter. So you do that on your calculator, and I'm going to write that out. Its pH is equal to negative, make sure you hit the negative sign, not the minus, but the negative. Not the subtract, but the negative. Negative 2 point, nope, sorry. Negative, and then you hit log, and then you hit 2.58 times 10 to the negative second. I want everybody in here to do that so that you are comfortable with it when you start to practice. All right, what'd you get? Done. There's your answers. Is this a strong acid or a weak acid? It is a strong acid. Good. If I asked if it was a strong base or weak base, what is it? Weak base. Very good. Super simple, yes? Okay, so you already know that this is not difficult. The problem is the wording. The wording is weird. Also, I want to mention to you this. It is not required that it has to be in scientific notation. I can give you a number that's not in scientific notation. You solve it exactly the same way. Okay? Okay. This one's a little bit different. Do you see what's different?
What's this hydrogen?
It's a different compound.
What do you mean?
Like, it's not exactly the same.
Tell me what's different.
It's a polyatomic.
Oh, okay. All right. Yeah, you're not wrong. See up here where it says pH and then hydrogen ion concentration, and that matches up? Here it says pH and hydroxide ion concentration, and that's not the same thing. That doesn't match. And so when those two things don't match, you're going to have to do one extra step. And it's a super simple step. You just got to remember to do it. Okay. So first of all, this is hydroxide ion concentration right here. So which of these equations do I have to use? Yeah, the bottom one. this one here. Do you see how that one's talking about hydroxide? Okay, so if I solve for that, am I going to get pH? I'm going to get POH. But let's go ahead and run with it. So I have POH is equal to negative log of 3.93 times 10 to the negative 12. And what did you get? No. 11.4? That is pH.
Wait, what was the, oh, you haven't said the other stuff.
Right. This is POH. I'm sorry, this is POH. Now, how do I get to pH? Right here. Subtract from 14. So anytime you solve the wrong one, you just subtract from 14, it gets you the right one. So my pH is going to be, 2.6.
Yes.
Is that a strong acid or a weak acid? Strong. Is it a strong base or a weak base? Weak base.
So whenever it gives you a POH and you want it to pH, just subtract it by 14.
Yep.
And then you do the opposite if it's pH and you need pH.
That's exactly right. Okay. Yes. You hit negative, and negative's at the bottom, log, and then the number that I give you. And if I give you in scientific notation, great. If I don't, great.
It does not matter.
Does not matter. Okay, now I want to talk to you about a couple of ways that it makes this difficult. The wording makes this difficult. So if I could have your attention for just a second. What if I don't tell you that it's hydroxide ion concentration? What if I just tell you it's an acid and then give you a number? If I tell you it's an acid and then give you a number, what is it going to be for? Is it going to be for hydrogen ion concentration or hydroxide? Yeah. If I tell you it's a base, then the number I give you is going to be hydroxide. Does that make sense? Yeah. Okay. So I don't have to actually tell you which one it is. I could tell you it's an acid or a base, and then you have to know. Also, what if I just say, well, you know what? I think that's good enough. I think you'll be able to figure out from there. Please read the instructions on this first worksheet on the front because it does ask you to do multiple things. All right, and you have the rest of the period. Easy button.